Welcome back, guys. We're just making a short video here to help you with your work out of the textbook. We're going to do some work on division, and I'm not sure whether you guys will be keen on that, but I do know that this is a problem area for a lot of students. And we're just going to, number one, the language. We often say when we do our division and we get the answer, we don't refer to it as a quotient, and we don't talk about the dividend being the number that we start with, and the number after the division sign, we don't talk about that as being the divisor. But certainly what I'm interested in is the remainder, and often we call that what's left over. So there's all this technical language that we need to firstly get our heads around and understand, and then secondly, I think this is a really good area where we can do a lot of productive work and show you a few different ways to think about how to go about the business of division. So one of the useful things I want you to think about is that multiplication and division are the reverse operations of each other. So one way we can always check our answer is to work backwards and multiply the numbers to see if we get the original number that we started with. So I'm really interested in this work here, and I hope you get a lot of value out of it. First thing we need to talk about is the language. What do we say when we're doing division? Okay, we often say how many times does something go in? We often say how much. And when you see those things in the question, it should say to you, we're doing some division. And we often say things like, does it go in evenly? And we say, what's left over? And when we're talking about this, I'll work this out in a minute. This is really interesting, and we're talking about remainders, what's left over. So let's just have a look at the symbol for division. Let's draw it out nice and big, and we've got a line called the vinculum, and we've got two dots, one above and one below, and we're wondering what they are. What does it actually mean? So I want to make a few links for you here. And this is really interesting. So we've got the division sign, what we're thinking about, and this dot up here is a number, some number, and the one below is another number. Okay, so the link here, I want you to look on your calculator and look for the fraction button. Do you see this? Do you see the same sort of symbol? Hopefully you do. If we're talking about fractions, you would say this is a numerator. And this button, this box here is the number on the bottom, the number that goes underneath the line, or however you want to describe it. And we would, if we're talking about fractions, we'd call this a denominator. So there's a big link when you're doing division between these two things. I see division as just working with fractions. Okay, keep it simple. 20 divided by, or how many, 4s. Okay, and we think about how many times 4 goes in there, and I think it's going to go in there evenly. We could possibly, if we thought back to primary school, we could perhaps make 5 groups of 4. Okay, so the answer there is 5. Okay, so if I set this up as a fraction, 20, 20, I read this as, I was nearly going to say it, still read it as 20, how many 4s? Okay, because if we cancelled this improper fraction down, we could say, how many times does 4 go into 4? We would say once. How many times does 4 go into 20? And it goes in 5 times. So the answer there is 5 over 1. But we don't write it like that. We just write it as 5 as a whole number. So to me, they look like very similar things. So I just wanted to provide a sort of link to you. And I'll just clean the board, and there's more technical language we need to talk about. We talked about the symbol for division. And we've got the vinculum and a little dot to represent a number above and a little dot to represent a number below. And we made a few. We've got technical language that we need to understand. Okay? So let's have a look at this. Let's use the same numbers again. We have 20 divided by 4, and we worked out that was equal to 5. So I'm just going to change the color of the pen here and write some words here that you need to know. And let's start with what you'll see in the book. They'll be asking you to find the quotient. And if we're talking, we'll just be saying the answer. Okay, but you'll see this written as a quotient. They're asking you to work out the answer, okay, but they're not using that language. We need to know and understand that. And there's other words that they're using, and that is, one of those words is a dividend. And that is referring to this number, the number that we start with, the big number that we're going to break apart into smaller groups, okay? And the instructions for the size of the groups is here, okay? And we call this the divisor. Okay, so you'll see there's one more word that we need to talk about. We need to set something up so we can talk about remainder. So let's set another question up here. Let's change one thing. Let's do 20 divided by 7. Okay, so we might know that 7 doesn't go into 20. If we remember our 7 times table, we've got 7 times 2 is 14, and 7 times 3 is equal to 21. So the answer to this will be, I can make 2 groups of 7, and I'm going to have something left over, and this is the language we need. We need to say remainder, R for remainder, and how many is going to be left over? We needed 1 more to make 21, so we've only got 6 left. Now, here's a link to the fractions. We can write 2 remainder 6 as a mixed number. So 2, and we use the vinculum there, and we're going to create a fraction now. And what did we divide by? Our divisor was 7, so that becomes a denominator. And what was left over? 6 was left over, so that becomes the numerator. And that's another way we can write the same information, okay? 2 remainder 6, or 2 and 6/7 are both acceptable ways to write your answers. At the top here, I've got the technical language. 20 is a dividend, the divisor is 4, and the quotient or the answer is 5 in this case. So I've just put a little box up here because this goes in evenly. The remainder is 0. Now I'm just setting up some examples that we can use. And the first one is 51 divided by 3. So I want to show you this short division algorithm, and what we do, you've got to be really careful about this because you can't get this messed up because the associative laws and commutative laws, they don't apply for division. So a dividend, which is this first number here, has to go under the short division sign here that I've drawn, and the divisor, in this case it's 3, goes out the front. So how do we do this? We're thinking about the 5 here is in the tens. Okay, 5 is larger than 3, so we can just say to ourselves, how many times does 3 go into 5? It goes in once, and there's something left over. There's 2 left over. So we shift that, and we've got to write a little 2 in here. We shift that into the ones column, and we think about this now as 21. How many 3s? And I think from a previous question we did 7 times 3 is 21. So that's 17, remainder 0. We don't need to write that part, but you can if you like. 84, how many 7s? And we can set up our short division algorithm. The dividend has to go underneath the sign and the divisor out the front. And now we can look at the 8, and 7 goes in once and there's 1 left over. And now we read this as 14. And we think about how many times 7 goes in there, and it goes in there twice. All right, with this one, I'm looking at 84. This is another way you could think about this. We can always apply some mental strategy. I'm thinking that is 70 plus 14. And both those numbers work. All right, I can think about how many times 7 goes into 70, and the answer there is 10. And I can think about how many times 7 goes into 14, and the answer there is 2. Add them together and we've got 12 as our final answer. So there's always another way to do this. So let's just practice a couple more. I'm just going to set up the algorithm straight away. So when you see these things written in your book like this, you can, once you get good at it, you can think about just writing this out and reading this. I'm reading this as 125 divided by 5. Now, look here. There's a little rule. If the last digit is a 5 or a 0, then 5's going to go in. So I know there's going to be nothing left over here. There's going to be no remainder. So I follow the algorithm, and this time I've got a bit of a problem. I need to think about those two numbers together, and I say to myself, 12, how many 5s? And the answer to that is 2, and I've got 2 left over. Okay, so now I read this as 25, how many 5s? And the answer to that is 5. So what we can do, it's probably a good time to just show you a little trick. And I'll change the color of my pen. If I multiply these two numbers together, I should end up with this. So let's try that. 5 times 25, I'm going to do 4 times 25 because that's easy, that's 100. And then just another 1 times 25, that's 25. Add them together and I've got 125. So I know that's right. you could apply those tricks here and check your answer and see if that works out, and that works out as well. So always with these types of questions, check, and if they go in evenly, then it's easy to check, right? So one more question here. I'm setting up the algorithm and I'm setting up my numbers, and I'm looking, I've got to do these first two together here. I've got to think about this as 13. How many times does 9 go into that? It's once, and I've got 4 left over, and that's handy because 9 goes into 45 15 times. Okay, so let's do the quick check. I've got 15 times 9. I'm going to think about that as 15 times 10, which is 150. Subtract 15, and that's equal to 135. Okay, so there we go. So in some ways, I think if we've got no remainder, then there's an easy check that we can apply to make sure that we've always got the right answer. Okay, recording in 3, 2, 1. Now this time we're going to have a remainder. And you might see this shortened to REM. You might see just an R. And of course, we understand that we can set the remainder up as a fraction, depending on what numbers we're using and what's left over. So let's have a look at a few of these questions here. And I'm going to go straight into the short division algorithm here. I've got 37 divided by 3. Now that's nice and easy because 3 goes into 3 once, there's nothing left over, and 3 goes into 7 twice, and there's 1 left over. So I can write that as 12 remainder 1. Okay, I'm looking at this straight away, and I was thinking, just applying some mental strategies here, I was thinking 3 times 12 is 36. So 37 is 36 plus 1. So there's our remainder there. So how are we going to write this one as a fraction? We're going to write our final answer as 37 divided by 3 is equal to 12, and 1 over 3 is one way we could write our answer. So let's try another question here, and let's do one more. Okay, so let's have a look at this. Let's do 6 divided by 435. Okay, so that looks, sorry, I probably messed that up. I should have said 435. How many 6s? All right. It's easy to get them mixed up when we just read left to right and write it this way. So let's have a look. That's tricky because I need to think about these two numbers together. I probably need to do some work out of the 6 times tables here. So 6 times 5 is 30. That's not close enough. 6 times 6 is 36. 6 times 7 is 42. Alright, so it's going in 7 times and I've got 1 left over. So now I'm thinking about 15, how many 6s? And 2 6s. 6 times 2 is 12, and I've got 3 left over. So I'm going to put a 2 here, remainder 3. Okay, so what does this look like? 435 divided by 6 is equal to 72, and 3 on 6. Now you can also do another little tidy up step here. You could call that 72 and a half, because we can simplify that fractions. You can do that if you see it, or you can leave it here. You just might see this in the textbook. It means the same thing. All right, so I've got one more thing to show you, and this is really interesting. It's kind of a mental strategy that we can use. What do we got? We've got 484 divided by 4. Now, if you've got even numbers, 2's a common factor to both these numbers. So you can do things like this. You can halve those numbers. So 240, and think about this as 242 divided by 2. And that's divided by 2 is kind of easy because we're in a halving game here. So the answer here is 121. All right. So we've done this work, and it just might pay to write it out again as a final statement. Divided by 4 is equal to 121. Okay. This is just purely a mental strategy that you can use when both the dividend and the divisor are even numbers, and they have to be both even numbers for you to do this. Okay, so I think that wraps up this video.